be seeing the role of indicators. Indicators work by changing to one color in acids and another color in alkalis. So if we look at the example we just watched, you could have seen that in methyl orange in an acid, it turns into a red color, or it remains red, right? And in a basic solution, we see a yellow. The solution becomes yellow, right? Phenolphthalein in an acid is also colorless. However, it starts to change to a nice pinkish color when you put it inside of a base because, all right, this is how indicators work, okay? They're supposed to change color in acids and bases. So here we have a universal indicator scale. And what do we notice when we look at this scale? Yes, you have pHs from 1 through 14. Very good. Another thing is you have the associated color for each of those pH. Okay, so it's going to give you a more accurate, all right? It's going to give you a more accurate pH. Instead of just telling you acid or base, it's going to tell you how acidic or how basic a substance is. So if we look at this, we see that the stronger the acid, the smaller the pH number. So a very, very strong acid will have a pH of 1. Whereas the alkalis, the stronger the alkali, the higher the pH. So a very, very, very strong alkali will have a pH of 14. Okay, so also note the different colors, okay? Acids go from red to orange being very weak, okay? And then you have yellow, all right, which is very, very, very weak. And then 7, green, neutral. And then we go to different shades of green, and then we go to blue, all right? And then we go to very, very, very dark blue, which indicates that it's a strong base. So now I want you to go ahead and look at this scale, and I want you to give me an example of a weak acid, a very weak acid, all right? Yes, if you said vinegar or if you said milk, then you would be correct. Name one substance that is neutral. If you said water or salt, you would also be correct. How about a very, very strong base? If you said oven cleaner, you would be correct. Good job.
Topic: Neutralization reaction. How to treat a bee sting.
Oh.
Hey, hold on. Don't go near that honeycomb. Please listen to me. It is quite dangerous. Fine, go ahead. See? I told you. Okay, now don't worry. Put this baking soda solution on the bee stung area. You got some relief, right? Do you know why you got relief? This happened because a neutralization reaction took place when we applied baking soda on the stung area. The venom of a honeybee contains formic acid. When it stings us, it injects that acid into our skin. Formic acid causes immense pain and irritation. However, when we apply baking soda solution, which is a mild base, on the stung area, it neutralizes the formic acid and cancels its effect. As a result, the sensation of pain and irritation decreases and we get some relief. Such a reaction between an acid and a base is called neutralization. In neutralization, both acidic and basic solutions neutralize the effect of each other, and the nature of both acids and bases gets destroyed.
So upon watching that video, you would have gained a better understanding of what neutralization is. So neutralization, this is the reaction between an acid and a base. Okay, and it's going to produce a salt, and it's also going to be producing water. Okay, so you have the H plus of the acid combining with the OH negative ions of the base, and that's going to give you a neutral substance, water. We look at this example here. This is neutralizing an acid. So during neutralization, what's going to happen is the pH of the acid is going to be changed. Okay, it's going to be changed to a pH that is neutral. Okay, so we can do this by adding an alkali. When you add alkali to an acid, the pH is going to be changing towards a pH that is neutral, which is 7. Next we have an alkali. Okay, so if you have an alkali, we know strong alkali's pH is about 14, 13, and if you want to go ahead and neutralize it, you're just going to be adding an acid. You're going to be adding an acid, and you're going to keep adding it, and then eventually the pH becomes neutral. Okay, which is 7. We're going to name salts that are formed when an acid and a base combine together. So we have different acids here: hydrochloric acid, sulfuric, sulfurous, nitric, nitrous, phosphoric acid. Okay, we have these acids, and then we have the formulas in this table here, which you need to memorize if you haven't done so already. And then also the salt and the ending for the salts. Okay, so look at the endings for the salts. So if you have remember, our salt is going to be made up of an acid and a base, okay? And if you have those two, the ending is going to always be the ending of the acid. And these are going to be the ending for each of these acids that can be used. If hydrochloric acid is used, ending is chloride. If a sulfuric acid is used, the ending is sulfate. Sulfurous, sulfite. Nitric acid, nitrate. Nitrous acid, nitrite, and phosphoric acid, phosphate. Okay. Also keep in mind, remember the polyatomic ions. The salt ending is also the same as the polyatomic ion name. Okay, produced by each of these acids. So now we're going to go ahead and name the salt. So to name the salt, we have to first put our positive ion, which is most of the time it is going to be our metal. You're going to have your positive ion, most of the time it's going to be a metal, and then you're going to have the ending of the acid. Okay, so let's go ahead and try it. So our first one would be name of our positive ion or our metal, calcium, and then the ending is that of the acid, which is chloride. So let's put it together, calcium chloride. Good job. Next one is, let's try the next one. Magnesium and nitric acid would give us, good job, magnesium nitrate. What about, it should be copper 2 oxide and sulfuric acid. Good job, you're doing really good. Next you have ammonia, and then you also have nitric acid. Remember, you could either have the positive ion or you could have your metal. Now we don't have a metal here, but we have ammonia, which is a positive polyatomic ion. You're going to have ammonia. Whenever ammonia combines, it changes from ammonia to ammonium. You're going to have ammonium, and then you're going to have the acid is nitrate. Good job. This right here is potassium, and then you have sulfate. Good job. Okay, keep in mind the only reason why there was a 2 in bracket is because it is a transitional metal. Transitional metal, whenever we're giving it a name, we have to put its valency in bracket. Here are a list of soluble and insoluble salts. Soluble meaning that it can definitely dissolve in water, whereas insoluble means that it cannot and it will not dissolve in water.